Hey everyone, I'm Christophe. I think most of the people in the audience know me. I hope so, maybe not, but so I'm co-organizing the event with DLT. And today I'm gonna talk about this idea that I had like when I was looking for a talk, so towards a simple future. So the idea is like trying to put words on the complexity that we built on top of every data platform that we have out there today. So the question that I had was, why did everything become so complex? When we look at the talk that we had just before, everything was complex because it's like aggregating stuff from like many companies, many M&A and stuff like this. But there are companies that are not in this process that have stuff that is too complex. So the idea of this talk is just like having a look at it, just giving you a heads up, and then at the end just going into like why DLT is simple, why DLT plus a few other things is like super simple, and what can we do. So it's gonna be like maybe a demo that I hope will work. So who I am, I'm Christophe, I'm a staff data engineer. I've been doing stuff for 10 years in the data world. Last year as a freelancer, I'm doing content creation and I'm organizing events. Next Monday, I'm doing like a big conference in Paris. And right now I've co-founded a company called Now with Claire that is in the audience, and we are reinventing or inventing the analytics engineering developer experience that does not exist today. I will talk about this maybe later. So what is required today to do data? Most of the time we think about like we need a platform and we need a team, and yeah, we won. But we often forget like we need needs. And this is just a wake-up call for everyone here, because like just before we saw like YAMLs, Python scripts, but those like YAML and Python script does not exist if we don't have like needs from like business teams. So just don't forget this. And most of the time also we talk about platforms because this is the easiest part. Like this is solved. Like platform with all the technologies out there, like everything is solved. But the real issues are like on the right side, so like between the team and the needs. And this is where you have to find like vision for data teams. Like a lot of teams struggle like finding vision, finding like the true purposes, the ROI of the data team and stuff like this. This is like the complex stuff. Like the platform part is not that complex. Also, on the vision side, there is an article from Alan. French people knows Alan, which is like a startup in the healthcare side. And they wrote like a medium article about what are like the mission of data team fulfill. And there are like two big ones. The first one is create insights. And the second one is build products. Products might be machine learning, whatever, you put whatever you want behind products. But the create insights is very important, because why do you create insights? You create insight to empower people to take decisions. And this is like something that you have to keep in mind when you are like working in a data team. It's like you need to empower people. You need to provide them stuff to be empowered. Your role is not to get the most fancy stuff to do a pipeline. Your role is like to write a pipeline that will empower someone to take a decision. So yeah, don't forget this. If I just now jump from like this thing that is like very high in the sky to more concrete stuff. What is a data platform? I really like to summarize like a data platform like this. This is not that complex. Yeah, you have data that goes in. You put this data like into a storage. You have an engine on top that does like some kind of computation, aggregation, whatever. You have code that run between the storage and the compute, and then you put the data out. This is just, a data platform is just this. So why do we need like many storage, why many engines? You have to figure out. And then around like these two main critical blocks, you have edge stuff, which is like the governance. So how do you orchestrate the stuff? Or where is the data, what you are looking for, catalogs and so on. You put whatever you want in edge. It's like a fourre-tout. On top of this, you obviously need visualization, because you have data, you have to provide some visualization to your businesses, and you also do machine learning. And when we look at roles and responsibilities, most of the time it's going to be like divided like this. let's say governance is for everyone, because like, yeah, company, we hope everyone in the company wants to do governance, but most of the time it's just data role. We have the engineers that are like mainly working on the storage engine, the way that the pipes that put the data in and the pipes that put the data out. Analysts are like on the visualization side, the engine, and the scientists on the ML side and the engine. So everyone like concentrate around like the engine. So the engine is like the critical part. If I put words, it's like your warehouse, Snowflake is the critical part. Databricks, if you are on Databricks, this is the critical part. So yeah, that's where like the data team interact. And then, so I have like this logical plan. And then when we look at the market right now, the market is like this. We have like many tools. Yeah, I have no words. So how did we end up having this logical visualization of like a simple data platform into this? I don't know. Maybe it gives like some tournis to few people in the room, like having like a Airflow DAG that is like this, or having like a data platform with like, yeah, pipes, like one relational databases, one relational data warehouse, yeah, I have stuff everywhere. So as developer, as data people, globally, we are just entropy generators. We just generate entropy, like a lot of stuff. So yeah, entropy is a scientific concept that is most commonly associated with the state of disorder, randomness, or uncertainty. And actually, when we look at my previous diagram, the three parts where we have a lot of entropy that we generate as data team is like on the data in, so on the ingestion. So we have like a bunch of scripts or whatever pipelines, DAG stuff that does ingestion. On the code, like between the engine, so in the warehouse, we have a bunch of SQL scripts, Python scripts with pandas, whatever, that does transformation. And on the visualization, we have like a dashboard symmetry with like a lot of dashboards that are unused by everyone. So this is just like the three main points where you're gonna generate entropy, whatever you do, whatever the process that you have in place, you will create entropies on these 3 points. So at some points, you will need to have some processes to keep your room clean, actually, like to clean the stuff, have processes to remove the dashboard that are unused, remove the SQL queries or the table that are unused, unqueried, and so on. So don't forget this. So let's jump into just like the flow to ingest data. So theoretically, I'm saying like you should aim for something simple. So just do simple thing. But actually, it's not that simple to do it in real life because we can materialize it like this. We have sources. We want to put it in the storage. But actually, there isn't one type of source. It's like common APIs. I mean, like Facebook, HubSpot, it's common APIs, but sometimes you also have like internal APIs, niche API that are not out of the box supported by all the tools in the market. You have relational databases and so on and so on and so on that you want to put in the storage. And from what I've seen everywhere, there isn't any one out-of-the-box solution that will support all the stuff that you want to ingest. It will always be like a composition of 2 or 3 tools. And so having this possibility like to have out-of-the-box stuff and be able like to customize with the same trust between both is something that is like critical in a system that ingests data. Yeah, okay. And then to add more complexity, when you do stuff, you want to do it locally because you develop locally. You also want to do it in staging or whatever you call the staging or in production and so on. So it piles up on like on the complexity. And if we add like what's after, oh yeah, I forgot there is one slide where I just switch between one storage to multiple storage. Because, yeah, whatever, we have multiple storage. And then after the storage, you have SQL. And then on the storage, you also have MetaSQL that lives in your BI tool, for instance. So it adds also on complexity, like you have BI, not BI, you have SQL in the warehouse, SQL in DBT, SQL in 1 BI tool, 2 BI tool, 3 BI tools, whatever, the number you have. So, yeah, complexity is like everywhere. But in the end, there is something I really liked in the current evolution of the data platform stuff. It's the concept of assets. like data sets that have been brought by Daxter mainly. They were the first like to conceptualize like the stuff as assets. And actually everything is just data assets. Extract and log generate data sets that we can consider assets. So it's a data set either like on blob storage or on a warehouse. A SQL generated data set that we can consider like a data asset. Dashboard are some kind of data set projection that we can also consider like assets. Dashboard can be considered like assets. And in the end, so it means that everything can be described as code. And something that we learned from like the software engineering world, which is every stuff that we describe as code can be governed with all the tools that we have in the software world. So with the CI/CD, with the versioning, with whatever exists in the software world. So my conclusion or the way I want to move in is we should just consider like all the data sets like stuff that is built by code. So we put all the routines that we use to maintain code to do stuff. And just, yeah, to add on the complexity, this is just this is a slide that I use when I teach data engineering. And I'm like, yeah, this is all the concept that we have in the course that we have to cover. This is all the stuff that you have to know, some kind of vocabulary concept that you have to know when you are doing data engineering. So stuff is just complex by default. But our goal as data engineer and software engineer that loves to solve problems is to figure out a framework or some kind of interpolation or some kind of stuff that will simplify how others interact with the stuff we build. So the example that Stellensis gave on like having a YAML on top of the ingestion is the way to simplify usage by others, plus create a standardization layer that is necessary because you don't want everyone to do whatever they want, because you will create complexity, entropy, and so on. So I propose just a North Star, which is we should all aim to govern assets through code with minimal complexity. What it means, I just propose like 3 KPIs that I just decided like this morning. But we could, for instance, like track the coverage. So the coverage, I mean the coverage of the data sets that you have that are governed in code, not code coverage in sense of test, more like how many of your data assets are governed in your code. This is like a first good metric to track. The second one is like the number of assets. I think if you look at the number of assets that you have, it's like a proxy of the complexity. You can also look at the number of assets per people in the data team. I don't know, maybe 20 assets per person is not that much, but 500 is maybe too much. So you can find like what the number for you that makes sense. And also the code complexity. Code complexity is something that we can measure today. So we're getting like the line numbers that you have in your code base, the code coverage in terms of test, and so on. And yeah, all of this, I just like, I'm trying to learn now. What about DLT? And what's like the relationship with DLT? So what I really like with DLT is that it's simple. You just do pip install DLT and you have something to work with. It's a framework. It's not like competitors, I would say that you have to install a lot of stuff like to run your first ingestion. With DLT, you just do pip install. You init the stuff you want to do, and you have data. I will do a demo for this, for the people that doesn't know DLT and how it works. But to me, if I just join with what I just said, is like DLT is a way to govern ELT assets with code. And it's a portable one, because you can do it like locally and use the same code like on production or remotely with just like config changes. Okay, I will just introduce my small demo and the stuff I just want to showcase, which is, so I have a blog where I have like a newsletter called Data News, where people on the blog can subscribe to support me. It's like just a small fee every month. I think it's like €6, something like this. Or if you take 1 year, it's like €60. Anyway, people that subscribe generate like a Stripe subscription, and so the data is in Stripe. And so my demo will be, I want to create a bar chart like this that will show my numbers per month since I've launched my blog and to see how many money I made. And the goal is, I don't know, in 5 minutes to get this chart. Without anything. So the idea is I have a source, I will use dltHub to put data in some kind of storage, so it will be locally on my computer. I will run some kind of compute on top of the storage. I could use one of this, but I will use one that is not in this list, which is DuckDB. This is why I've switched. And then I will use another thing that is called Yato, which is like a library that I've developed that simply orchestrates SQL queries in a folder. So it's DBT, but DBT is too complex to me because you have to run a lot of queries and CLI stuff to do it. Yato is just like Yato run, you give a SQL folder and it runs like the queries in the right order. This is a small library, you can give it a try if you want. Yeah, that's my profile on GitHub, almost 200 stars. If everyone starts right now, I might be reach it. Just I say it like this. And to finish, I will try to do like the bar chart in evidence, which is like a BIS code technology. Okay. Oh yeah, and just it's largely inspired by this concept of modern data stack in a box, which is a small footprint modern data stack around like DuckDB. So let's go about the demo. I will do it with one end. So if I do it in 5 minutes, it's good. Yeah, it might be like crazy good. So let me maybe zoom in a bit. So I am in a folder called DLT42. Guess why? If I just ls, there is just one folder which is viz, which is like the evidence configuration. I don't want to write it because it's a bit too big. So there is just this folder that will wait for like the data to go in. So I have already a virtual env created in which I have DLT installed and Yato. So what I will first do is DLT init. So because I want to do stuff with Stripe, I will init Stripe analytics, and I say I will use DuckDB as a destination. So I let DLT initialize the stuff for me. Then now I have like a folder with a few things in it, like a requirement, a first pipeline, and a folder with endpoints and provider and so on. I should do like the pip install requirements, but as I did already like the run, it's okay, I don't need to do it. And if I just open my PyCharm, not this one, is it like, yeah, maybe I zoom a bit. So I have a first boilerplate code. What I will just do is remove the stuff that is not that interesting for me. So for instance, I don't want to run an incremental ingestion, so I removed all of this. There are like some comments here, I don't care about this. Okay. And then, yeah, I don't want the dataset to call Stripe updated, but just Stripe. And the endpoints I wanna call are just invoice, for instance. Yeah, Copilot knows that I'm doing a demo, so he promised me the stuff that I've already written, I guess. And if I just, there's just this stuff. If I just do Python Stripe analytics pipeline, so the secrets are already set up in my computer. So that's why you don't see my Stripe private key. And if I look at the folder right now, I have a Stripe analytics DuckDB file that I can open, DuckDB, Stripe analytics DuckDB. And if I do show all tables, I have like a few tables that have been already like ingested in my local DuckDB. And here I have a table called invoice, in which I have all my invoice. I can check that I have all my invoice. If I do from, no, let me just use Stripe. Sorry, I typing beforehand. From invoice, select count. Yeah, I'm just flexing a bit like DuckDB doing the keywords in the reverse order. So yeah, I have almost 150 invoice in it. And now I want to create a table called revenue, in which I will have like my revenue per month, okay? So in order to do it, I go back in PyCharm. I create a folder called SQL, in which I create a file called revenue.sql. I guess that Copilot will understand what I want to do. Please, Copilot. Yeah, he proposed me something from Stripe invoice. Cool. And here is a bit stupid. He say it's a year, but I want by month. Okay. And please, yeah, group by all, it's okay. Group by all or by months. Okay, so now I have like my SQL query that has been written. Now I can try this SQL query. I can either like run it directly in DuckDB, or I can use Yato to run it. So if I go outside of this and do Yato run and give the database, the DuckDB database, and give the SQL folder, I press enter, and Yato run my SQL query in DuckDB. So I go back in my DuckDB, show all tables. I have a table called transform revenue. So if I do select star from transform.revenue, I have a table with all the months and the revenue in it. Okay, and that's all I can get the stuff from Stripe directly in my computer in less than 5 minutes. And if it works well, I can also have a chart if I just run evidence locally. Finger crossed. I have a chart. So the chart is like just plugged to the data that I got like in the DuckDB database that I have locally, and it's displayed here. If I just show you like the evidence code, it's like pretty simple right now. There is an index. I just do like a select query, which is because it's a metric, so you still need like a query like to get the data. I say I want a bar chart on the revenue per month revenue, and I don't want a sort, and it gives me this. Yeah, that's mainly it. I go back to my presentation. What's after this? Ah, yeah. Obviously, there are like some limitation about the stuff that I showcase. It's like locally, it's like really cool, like for hacky stuff. I mean, like as a solo developer, like for side projects, like it works well. How does it work in enterprise context? This is your job to to figure it out. But it's like what Stellantis showcase, like with having YAML, creating standards, creating like a layer on top of the library, creating like your own framework on top of the library is a good way to start. Also, what I did here is I have a small SQL query. Having small SQL query everywhere can lead to like a lot of fragmentation and having like not a correct data modeling, I would say, or like you will get a fragmented data modeling. So you have to have it in mind, not to have stuff everywhere. So still standardization need. A lot of data team have been built as a mix of people that are coming from the software engineering world and people that are coming from the data analytics world. That most of the time, when they are coming from the analytics world, lack of software engineering skill. And sometimes it's like super hard like to onboard them on this kind of tools. So it's your role like to onboard them, to help them like upskill and so on. And the last thing is like going from stuff that has like legacy or complex legacy, I would say, into like stuff that is complex, require like change management and so on. So yeah, you understand. And yeah, that's mainly for the limitation. I think, yeah, I'm almost out of time. And to conclude this, I have one more thing, which is Now, which is like the company I've co-founded. With Now, we are building an IDE that understands the data work. So what I just showcased right now, when I was developing, I was like in my PyCharm switching to the terminal. Obviously, I could have like the terminal in PyCharm, but still, what we feel is that the IDE that exist today are meant for software engineering. They are not meant for data work. They lack so much context in terms of data work, like showcasing the data, displaying the data correctly, doing like manipulation with data, even like cursor or LLMs doesn't have like the context of your data. And so our goal with Now is to build the next generation IDE that will understand all your data work in order like for you to craft your modeling faster, better, and without like breaking anything, and so without also waiting for like the CI to run for 40 minutes, 1 hour, I don't know, like until you get the diff on your production. So we are like in the phase where we are looking for design partners to build this idea. So if you wanna try out or just help us build it, reach out to me or Claire that is just here with my co-founder. And so that's all from me, and thank you.